Good morning, this is your Stat Sensei, Mr. Spensei, and this is a chi-square goodness of fit, and the scenario is know your place. So, a grocery store manager wishes to determine whether a certain product will sell equally well in any of five locations in the store. That sounds pretty important because it says, hey, how many locations are there? Five locations, and they want to know if it's equally well. Awesome. Five displays are set up and each product is randomly assigned. Okay, so random assignment, we know that's important because that random assignment is going to impact one of our conditions. All right, the resulting sales numbers for the week are given in the table below. And it said, okay, location one had 43 sales, location two had 29 sales, location three had 52 sales, location four had 34 sales, and location five had 48 sales. So I went ahead and I put that information into my calculator. I see, and I have, there it is. You know what? I'm going to clear that out for just a moment. So 43, 29, 52, 34, and 48. And I can go stat calc one var stats, and I don't have a frequency in there, so I'm going to clear that out. But my list was an L1. And when I do that, I go, oh, we had a sum of 206. All we did was say, hey, 43 plus 29 plus 52 is 34, 48. Though that all, when we added all those together, that equaled 206. Great. All right, so that tells me my total, all right, my total number of sales. So is there evidence that location makes a difference? Test at the 10%. So we have an alpha equals 0.10. Well, we're going to go ahead and drop down and look at our chi-squared formula. Our chi-squared formula is observed minus expected squared over expected. And that's the formula, but we're going to have to do it multiple times. So plus, so the first one, and we'll just show the last one. All right. So we have that, but we go, oh, we have our observed values. We observe 43. These are all observations. That's an observation, that's an observation, that's an observation, that's an observation, and that's an observation. But we don't have our expected values. But we know something. We know that we have 206 sales and we have five locations. So we're just going to take that 206 and divide by five. So I'm going to go back to stat edit. We know our total is 206 and then 206 and 206. And you're like, what are you doing? That doesn't make a whole lot of sense. But if I go up to the top, I can go blue 2 divided by 5. And it's like, oh, we expect it to be 41.2 for each one. So that's our expected value, and that's where that 41.2. And if we add the 41.2 up five times, it'll also equal 206. Well, at this point, we actually have enough information to go ahead and plug into our formula because our first observed value was 43. This is our expected, and this is our expected. Our last observed value is 48, and this was our expected, and this was our expected. Just make sure you have the little squared up there, but because it's observed minus expected, and we're just going to do the first one and last one, right? We'll do the first and last, and that's all we're going to show for work. Now, since we already have everything, we have our observed in L1, we have our expected in L2, we can actually go ahead and run this test. And we go stat test chi-squared goodness of fit. We go L1, L2. Now, your calculator may have a different degrees of freedom. We need to talk about how to find the degrees of freedom. Well, in this case, I have one, two, three, four, five, five levels. All right, five locations, five levels. So five. This is known as five categories. And degrees of freedom equals categories minus one. So in this case, our degrees of freedom are going to be simply 5 minus 1. All right. So our degrees of freedom will be 5 minus 1, which is 4. So it's like, okay, we can plug in a 4. And we press calculate. And we end up getting a chi-squared value. You know what? I'm going to go back just in case I didn't have that on screen. Stat test. And by the way, there's two chi-squareds. We're doing goodness of fit right now. So GOF or GOF for goodness of fit. L1, that's where my observed, expected was L2, and degrees of freedom were just 5 minus 1. And we get a chi-squared of 8.9029 and a p-value of 0.0635. We'll talk about the contributions later on in this video. So if I was drawing my graph, which I can now do, all of our chi-squareds are going to be skewed to the right, so they'll all be skewed right. This will always be at 0. We always start at 0, and we're always to the positive side. So in this case, there's our chi-squared value, 8.209, 8.9029, and we shade it to the right, and our p-value is 0.0635, and that's the area in this tail. Well, what type of test are we running? Well, we're running a chi-squared goodness of fit. And when we said stat test, that was letter D on the calculator. So I'm going to put a D here just so you know where you went. But chi-squared goodness of fit, just don't put the chi symbol, write the word chi. And please don't say chi, it's chi-squared goodness of fit. So our null and alternative hypotheses, they're going to be a little bit different than what we've done before because they'll be sentences. Each of the 5 locations has the same sales of the product. Just because they said, hey, we were expecting equal sales of the product. All right. The next one, at least one of the 5 locations does not have the same sales of the product. Super important that you go with that at least one. We need this word each and this phrase at least one. We're going to be using those over and over again for all of these. So each of the 5 locations has the same sales of the product. At least one of the does not have the same sale. All right, so that's our hypothesis statements. The next one, our conditions. Well, we have 3. We need randomization, and it's a random assignment of 206, and that was given to us, so we can check that off. Normally, we'd have to do the n times 10. We would normally do the n times 10, but in this case, they said it was random assignment, so there is no number 2, so that's why we scratched it out. All right? And then we have to make sure all expected values greater than 5. Well, we're not going to sit there and do it twice, but what we're going to go is see the table above. And what are our expected values? Our expected values in this case, all of our expected values in this case were 41.2. So our expected values of 41.2, they're greater than 5. You don't need to write it down, but I'm going to this one time, 41, because they're all the same. 41.2 is greater than 5. All right, so all expected greater than 5. We can check that off as well. And once again, these are expected values that I'm circling here in red. This is what you expected to get. And remember, we said the expected values were in, when we ran the test, it said stat test, chi-squared goodness of fit, L1, L2, calculate, the expected were in L2. Well, what did we have in L2? 41.2. Those are our expected values. All right. So we ran the test. And we got a chi-squared of 8.9. And that's equals a p-value 0.06357. Okay. And 0.0635 is less than our alpha of 0.10. So we reject the null. So our conclusion is going to be similar to what we've done before. Our p-value is 0.0635, which is less than our alpha 0.010. We reject the null. There is sufficient evidence to suggest, and look at this, suggest at least one of the 5 locations does not have the same sales of the product. Well, what is that? In the past, this has always been our alternative hypothesis. This has always been HA. So let's go look at HA. At least one of the 5 locations does not have the same sales of the product. This, once again, is still HA. All right, so our sentence stem is almost the same, and we're still restating the alternative hypothesis. Sure hopes this helped, and sure look forward to seeing you on the next one. Thank you.